Listen, I am Dr. Jayanta and your physics teacher. Okay, I will teach you the physics. In the physics, what's happened? The subject name is physics. And the code is PH101. That is the code of the subject. So I have already sent you the syllabus. Okay, have you got it? Physics syllabus. Okay, so that is the tentative syllabus. Why? Because as you know that now our college is autonomous college, autonomous institute. Okay, so we have to approve this syllabus from the board of study. After then, it will be the final syllabus. Okay. So now, from today we start the syllabus as per the syllabus which I have given to you. Okay. Now, in the first module there is the vector. Okay. Vector algebra and vector calculus. So we will start from the vector algebra. We have already studied the vector algebra in the class 12. Okay, but here we have to recap the vector algebra. Okay, so at first, what is a vector? Anyone? What is a vector? Okay. The quantity which have the magnitude as well as the direction is called vector. Okay. It is denoted by A. Okay. And for my class, you must have a separate notebook. Okay. I will give you the note and I will dictate the class. You have to write it in the notebook. Okay. For the theory portion, my note is enough. From the book, we have to only solve the numerical problem. Okay. So from the next class, you must have a separate notebook for my class. So this is the vector A. Now the vector A is written as A equals to AX I cap plus AY J cap plus AZ K cap. Okay? Where AX, AY and AZ are the components of the vector A along X, Y and Z axis. Okay? So what is a vector? There is no vector. The quantity which has the magnitude as well as the direction is called a vector. It is written as A with the arrow in the head, and A equals to AX I cap plus AY J cap plus AZ K cap. Okay? Where AX along x, y and z axis. So if we draw x axis, y axis, z axis, okay, and the vector A here. Okay, the unit vector along x axis is I cap, along y axis is j cap, and along z axis is k cap. Okay, then AX, this is the AX. How we get the A? We could take a projection here, projection of the vector A in the xy plane, and if you draw a perpendicular from here to here, then this is AX. If you draw a perpendicular from here to the y axis, that is AY, and if you draw a perpendicular from here to here, that is the AZ. Okay, so these are the components AX, AY and AZ, and where I cap, J cap, K cap are the unit vectors along X, Y and Z direction. Okay, unit vectors along X, Y and Z direction. Now draw the figure and write out. Now the unit vector. What is the unit vector?
Unit vector has magnitude 1, 0 to 1.
Unit vector which has the magnitude is 1 unity and has the direction same as the vector. Okay, that is called the unit vector. Okay, so the unit vector is defined as. So the unit vector is defined as A cap equals to vector A by magnitude of A. Okay? Vector A by magnitude of A. Like a unit vector. Unit vector. The quantity of the unit vector is defined as the ratio of the vector and the magnitude of the vector. The ratio of the vector and the magnitude of the vector. Okay? Where the magnitude of the vector is given by A equals to, what is the value? AX square plus AY square plus AZ square. So we get the unit vector. Okay, AX square plus AY square plus AZ square a root over. That is called the unit vector. Now the resolution of the vector. Okay, resolution of a vector. Any vector can be resolved. Any vector can be resolved into component vectors along three axes. Okay, if the angle between vector A and x-axis is alpha, vector A and y-axis is beta, and vector A and z-axis is gamma, then we know the vector A equals to ax I cap plus ay z cap plus az k cap. Therefore, magnitude of A equals to, or we can write it like that, magnitude of A equals to root over ax squared plus ay squared plus az squared. Equation 1. Equation 1. Now, the components ax equals to a cos alpha from the figure. From the figure we get ax equals to a cos alpha. Okay. Similarly, ay equals to a cos beta and az equals to a cos gamma. Okay, components of A along x, y and z axis, where alpha, beta, gamma are the angle between A and x axis, A and y axis, A and z axis. Okay. Now, if we put the value of ax, ay, az in equation 1, then what happens? From equation 1 we get, if we put it here, or a equals to root over a square cos square alpha plus a square cos square beta plus a square cos square gamma. So this is equals to a root over cos square alpha plus cos square beta plus cos square gamma. So a cancel, therefore cos square alpha plus cos square beta plus cos square gamma equals to 1. We get, this is cos square gamma equals to 1. Okay? The components ax equals to a cos alpha, ax equals to a cos alpha the components ax equals to a cos alpha, ay equals to a cos beta, and az equals to a cos gamma are called direction cosine. Are called direction cosine. Why? Cosine means cos. There is the cos, so it is called the direction cosine. Okay, direction cosine. This is equation 2. Equation 2. From equation 2. From equation 2, we can see that the sum of squares, the sum of the squares of the direction cosines, the sum of the squares of the direction cosine is unity. The sum of the square of the direction cosine is unity. Okay, so cos square gamma alpha plus cos square beta plus cos square gamma equals to 1. So you must remember this component, how we resolve the vector in 3 components. Okay, so this is the resolution, because you have to apply it after in the higher semester also. Now we go to the vector product. So we go to the vector product. What is vector product? Product of the 2 vector quantity. Right? Product of the 2 vector quantity is known as the vector product or product of the vector. Product of 2 vectors. Product of 2 vectors. Product of 2 vectors. Okay, number 1, scalar or dot product. Scalar or dot product. Scalar or dot product. If the angle between 2 vectors A and B, if the angle between 2 vectors is A and B is theta, then the dot product of the vector A and B is written as A dot B is written as A dot B equals to AB cos theta. A dot B equals to AB cos theta. So we can see that the dot product of 2 vectors is a scalar quantity. Now this is a scalar quantity. Okay, in the right hand side there is no vector quantity. So the product of the dot product of the 2 vector is a scalar. Okay. Now A dot B. The dot product of 2 vectors is a scalar. properties of scalar product. Properties of scalar product. Properties of scalar product. Number one. Scalar product of two vectors. Scalar product of two vectors obey commutative law. Obey commutative. C-O-M-M-U-T-A-T-I-V-E. Commutative law. What is commutative law? That is A dot B equals to B dot A. That is the commutative law. A dot B equals to B dot A. As it is not a vector quantity, so we can write anything, A dot B or B dot A. Same thing. Number two. If two vectors A and B are mutually perpendicular. If two vectors A and B are mutually perpendicular, then theta equals to pi by 2. Then cos theta equals to cos pi by 2 equals to 0. Okay, therefore A dot B equals to 0. A dot B equals to 0. Okay. Therefore, I dot I. 1. Why? I dot I equals to J dot J equals to K dot K equals to 1. Because the angle between J and K is 0. Cos 0 is 1, and the unit vector, the magnitude of unit vector is also 1. So it is 1. And I dot J equals to J dot K equals to I dot K equals to 0. Because they are perpendicular to each other. Okay. Number 3. Scalar product of two vectors is distributive. Scalar product of two vectors is distributive. That is A dot B plus C equals to A dot B plus A dot C. This is known as the distributive property. A dot B plus C equals to A dot B plus A dot C. Distributive property. Number 4. The scalar multiplication is associative. Scalar multiplication is associative. CIATIV, associative, full stop. If Mn are two scalar quantity, if Mn are two scalar quantity and A, B are two vector quantities, then MA dot NB equals to MN A dot B equals to NA dot MB. This is called the associative property. Okay, so these are the properties of the scalar product. Physical application of the scalar product. Physical application of scalar product. Physical application of scalar product. Number one, work done. Work done. The work done by a force F, the work done by a force F, by a force F causing a displacement D. Displacement is a vector quantity. Okay, causing a displacement D is given by W equals to F dot D is given by W equals to F dot D. Okay. W equals to F dot D. Now, number two, power. What is power? Anyone? What is power? Rate of work done. Okay. So the power is defined as rate of work done. Okay. That is P equals to dW dt. P equals to dW dt. So this is equals to ddt of W. W means F dot D from equation 1. Okay. So this is equals to F dot ddt of D. This is the displacement. So what is ddt by D? Velocity. So this is equals to F dot V. So power P equals to F dot V. That is our dot product. Okay. So these are the application of the dot product in physics. P equals to F dot V. Number 3, electric flux. Electric flux. Electric flux. Let us consider an elementary area ds. Let us consider an elementary area ds. So area is a vector quantity. Okay, what is the direction of the area? Perpendicular to the area. So if it is the area, then this is the direction. Okay, so ds. Let us consider an elementary area ds. ds in an electric field. In an electric field E. In an electric field E. Okay. Then the electric flux. Then the electric flux is given by. Then the electric flux is given by phi E. Phi E equals to E dot ds. So we can find out the flux with the help of the dot product. Okay. Similarly, we can find out the magnetic flux. Okay. Magnetic flux. Magnetic flux. Phi V equals to V dot S. Magnetic flux is V dot S or V dot ds. Indicator. Indicator পড়ো। Indicator এখন দরকার নেই। আমি একটু ডট করে অ্যাপ্লিকেশন। তখন ডিএসএ ইন্ডিকেটর টোটাল সাব হবে একটু ওই ফাইন্ডারের টোটাল সাব let me define লিখতে পারি। application of the dot product to write যখন টোটাল ফ্লাক্স বের করব then d phi equals v dot ds and phi equals indication of d dot ds ds indication এর 4 pi আসছে okay now we go to the vector product or cross product देखो vector product or cross product or cross product the vector product between two vectors A and B the vector products between two vectors A and B making an angle theta with each other is written as cross B equals to AB sin theta n cap. AB sin theta n cap. Okay, where n is the unit vector. Where n is the unit vector. N cap. N cap is the unit vector. So you can see that the vector product is a vector quantity. Okay, the vector product is a vector quantity. Then what is the direction? Thumb rule, according to the right hand thumb rule. Okay, the direction of the resultant vector. The direction of the resultant vector is according to the thumb rule. According to the thumb rule, right hand thumb rule. So what is the right hand thumb rule? A cross B. If we put all the fingers from A to B, then the right finger denotes, then the thumb finger denotes the direction of the resultant. Okay, A cross B. But if we take B cross A, then it goes in the downward direction. Okay, because now all the fingers are from B to A. Okay, so that is known as the right hand thumb rule. Okay, so this is the A cross B. If A equals to AX I cap plus AY J cap plus AZ K cap and B equals to BX I cap plus BY J cap plus BZ K cap, then A cross B equals to I cap J cap K cap AX AY AZ BX BY BZ. Determinant. Okay, using the determinant we can find out the A cross B. Okay, and then if A and B is this one, then what is A dot B? A dot B equals to AX BX plus AY BY plus AZ BZ. Because I dot I equals to 1, J dot J equals to 1, A dot K equals to 1. Okay. The properties of vector product. Properties of vector product. Properties of vector product. Properties of vector product. Number 1. Number 1, vector product does not obey. Vector product does not obey commutative law. Vector That is A cross B equals to minus B cross A. A cross B not equals to B cross A because it has a direction and the direction is opposite. So it is minus. So commutative law does not obey by the vector product. But in case of scalar product or dot product, A dot B equals to B dot A. That is the commutative. Okay. Number 2. The distributive law for cross product, holds good. HOLDS holds good. The distributive law for cross product holds good. That is A cross B plus C equals to A cross B plus A cross C. Number 3. If we take I cap, J cap, K cap, okay, then the cross product of I cap cross J cap equals to K cap. And J cap cross K cap equals to I cap, and K cross I cap equals to J cap. So we have to take in the anti-clockwise direction. Then it is positive. If we take clockwise direction, then J cross I equals to minus K. Then clockwise direction is J cross I is minus K, I cross K is minus J, K cross J is minus I. Okay? So that is the I cross J, sorry, J cross, K cross, and K cross, I cross. And I cap cross I cap. Yeah, zero. Why? Because I sin theta. Sin zero. Sin zero is zero. So I cross I equals to J cross J equals to K cross K equals to 0. Now the physical application of vector product. Physical application of vector product. So number 1, momentum of a force. Momentum of a force or torque. momentum of a force, about a fixed point is written as tau equals to, yes, yes, tau equals to r cross f. What is r? R is the perpendicular